Hey everyone, this is Johnny Dew. This is the Transformative Vertical Fly Working Group Public Services Meeting number 97. Today is Thursday, April 24th, 2025. We have two major topics to cover today. The first one is a white paper update. We'll talk about eVTOL for wildfire management and response. Dr. Pavel is going to lead us through the discussions. The second part, I thought we have a little fun. We've been having a lot of serious discussion for a while, and maybe we'll have a little fun on the second half of the discussion on the meeting. So with that, I'm going to, as usual, while other folks are signing in, going to start a little update on some of the uh, meeting. Now, if I can figure out how to advance my slides, I'll be in good shape. Uh, Hold on. Let me see. How do I advance my slides? Oh, there you go. How's that? That seemed to work better.
We're
All
not
right.
we're not seeing your slides.
Oh,
Are you
you're not?
sharing?
You're not seeing
Or
the slides?
I'm not.
Huh. Anybody seeing the presentation?
I've got the meeting, lecture, and conference slide, Johnny.
Me too.
Okay. You see the conference slide? That works?
Hey,
All
Fun.
right. Good deal. Anyway, we have some interesting meeting coming up. One is May 6th to 8th in Vancouver. Going to be the SAE Aerotech. Of course, May 19th, 22nd is going to be the Exponential, probably the world's largest industrial heavy-duty drone conference. And we also have the European Business Aviation Convention exhibition coming up on the May 20th, 22nd in Geneva. Heavy duty conference coming up the same dates, unfortunately. The Forum 81, we always know that there's a lot of presentation, technical paper, heavy duty discussion on anything related to vertical flight. That's going to be May 20th, 22nd in Virginia Beach. So strongly encourage anybody who can make it to attend. And also in June, oh, I'm sorry, that's a wrong date, so forget that. I somehow copied the old uh, page, so let's move on to the next page. As I say, the first topic we're going to talk about today is about the white paper we're working on with Dr. Pavel as the lead regarding the wildfire management and response. We're going to talk about, mainly thinking about or try to address how can AAM eVTOL technology and operations be used to make a difference in fighting wildfires. Updates on the progress and key focus by Dr. Pavel, and some discussions together. Hopefully, we'll bring additional key points to the table. There's a couple of key points I'd like to at least throw on the table right now, right here. One is for many of this mission that we're talking about, the mission endurance could be critical. The battery technology continues to advance and the mission usable flight time is getting better, but still charge time and so on, turnaround time, still potentially a challenge for many of the public service missions, especially in firefighting. So that linked to logistic response time and mission turnaround time. So the hybrid power system may be an important area to take a good look at. How can that, we're trading some payload perhaps for the endurance, but and the complexity, but the mission may dictate some kind of range extension or flight time extension capabilities. And we also need to probably, not every area that prone to wildfire can have enough eVTOLs sitting around. So we may have to converge and transport some other eVTOLs either by relay flying over or wildfire zone. That's transport and deployability. And a key area that we briefly mentioned that last time is the high gust tolerance. This time around in the California wildfire, we learned that the pretty unique situation, but it's not unheard of, the wind gusts reach up to 100 miles per hour. That in some cases grounded a lot of support, firefighting airplanes, helicopters, and all that. My question for the team is, technically, is it possible to design an eVTOL maybe with higher power reserve, maybe with much responsive control, maybe smaller rotor that has a low inertial that can respond direct drive very rapidly, and or with medium-sized rotor like Archer, Joby type design size and so on, that was a blade pitch control that can respond quickly. But can we get to the point that can allow us to fly in much more challenging gusting condition? Because even without the heavy gust generated, when you fly over fire zones and so on, the thermal can generate quite a disturbance in the flight characteristics. So, I mean, the picture on the right is, kind of show you how intense the situation can be. I think that's one of the area that I'll be very interested to figure out together. Is it feasible? How high a gust tolerance can we configure in eVTOL? And the other few things like landing on unprepared landing sites. You don't know where you're going to go into, where you can pick up and evacuate people and so on, or pick up and rescue firefighters and so on. So that ability, we may need some intelligent and maybe robotic landing gear or something. And of course, autonomous, we want the vehicle almost capable of flying itself most of the time. And so relieve the burden from any operators, firefighters, first responders. They don't have to be an expert pilot to really make the best use of it. And of course, distribute on demand. Like I kind of mentioned that several times. So that's without saying that when we need it, when you want it. That's the easy way to put it that way. So with that, I'm going to stop my sharing and pass the presentation to Marilena.
Okay. Thank you, Johnny. Okay. So I think you see me. Good evening from Europe, and thank you for being online. My name is Marilena Pavel, and I work with Johnny for quite a while in this TVF group. And I do this because I do believe that it is very needed for public services, the future mobility. And we published the first white paper, and basically we already start from last year to think of a new paper. And when the wildfire in January arrived in California, I thought this is a subject that can be very interesting for a new paper. So I prepared a few slides because I'm thinking on the different areas that we can work on. And those are just ideas. Probably there are different of Johnny's ideas in some areas. And I don't know all the solutions, but I will try to prepare to present them. Do you see my slides?
Yes, we can see it.
Yes.
Thank you. And I'm going to go in the presentation mode. So my thought is to call this white paper that we are going to write using AM and eVTOL technologies to transform wildfire response, and to have a subtitle like Innovative Approaches to Faster, Safer, and Smarter Firefighting. I will try to present you the thoughts of my chapters, the storyline that I'm thinking of. And the way that I'm thinking, if I can advance my slides, yes, is to start from with an intro and to present a kind of traditional firefighting problems. And I try to put them in different areas. So, for example, one of the problems of the traditional firefighting problems is the slow response times, that the fire can grow exponentially in the first hours, remote terrain delays, limited accessibility. Many fires start in mountains, forest areas. Ground vehicles are difficult to reach. Helicopter needs runway, or planes, so the problem of planes, they need runways. They have a high risk to human life. A firefighter exposed to unpredictable extreme conditions. Aerial operations are dangerous. And here it comes the windy environments. Resource constraints. There can be a limited number of aircraft and trained pilots. Fire seasons now stretch longer, so there are more problems. Budget, which are forcing tough choices. Lack of real-time intelligence. The fire moves fast, information is often outdated. Environmental and community impact. Late or inefficient in responses, which increase the fire damage. More houses and infrastructure will be lost. Smoke pollutants. Heavy fuel use and emissions. Traditional aircraft rely on fossil fuels, contributing to pollution. And coordination challenges. So I will give then a kind of, I will write this introduction. I will give as an example the LA fires, where you remember in January I was telling to you that this kind of fire was entirely foreseeable, and it was kind of worst case scenarios experts feared. So I downloaded, for example, a whole report from 2-3 years ago on a firefighting that was as well in LA, and you see coming back the same problems. And then after this kind of traditional presentation of the problem, I believe that we can move to say, okay, what do we need? What does it matter to fight the fires? Well, because it's about saving lives, protecting nature, building a safe and more resilient future. Now, wildfires are also increasing, so it means that there is an opportunity, and that is with the advanced air mobility, which is a kind of game-changing offering capability. And then I try to summarize some key features that can help in firefighting. And I divided them in technological, organizational, environmental. This will be a kind of new chapter in which we say, okay, these are the possibilities of the new AM, where you see the operational flexibility. They can operate in locations which are largely inaccessible. So I'm thinking as well, for example, of fighting with more drones. Ensure quick response data and front light. Ensure better mobility. And network stability in disasters. Then, organizational, quickly deployable to fire zones, flexible operations, efficient fleet management, synchronization for perimeter surveillance, for fire suppression, and and data collection and real-time communication. Environmental, of course, there is this zero emission and cleaner aircraft, noise reduction, minimum fuel consumption, so all the positive of the AAM, reduce our environmental footprint, minimum ecological disruption. So this will be kind of possibilities that the AAM will bring. But the AAM is also bringing a lot of barriers. And I took this, for example, from a review on the humanitarian drones, which summarizes a bit the barriers to drones in humanitarian logistics. And again, here, they are divided to the different areas in technological, organizational, and environmental. So first, there is a lack of resistance to harsh climate condition, limited battery life, limited payload, network delays, limited bandwidth, localization inaccuracy, privacy intrusion, lack of effective credentialis mechanism, insecurity and fear. Organizational, immaturity of drones, lack of financial resources, high investment costs, lack of user skills, need for training, user acceptance, negative public perception. And environmental, there is a lack of regulation, a slower bureaucratic nature of disaster response, lack of well-defined standards, accountability and responsibility issues, and regulatory uncertainties. Now, all these are barriers in order to accept the future air mobility for the firefighting. But the point that probably we should as well make in a paper is that there are new technologies that can help and that will change the way that the firefighting is seen in the future. And I summarized a few of them here. The first thing that is happening at the moment will be the AI. And I believe that at the moment, these AI predictions in the wildfire are fundamental because they are able to detect much more and complex nonlinear relationships, having different variables: wind, speed, vegetation type, humidity, temperature, and human activity indicator. So basically, we work as well on the AI, not so much. I work on a vehicle system, but there are some steps which are needed to advance the AI role in the wildfire management. And those steps are taken through this satellite. Because at the moment, there are satellites more and more with an active fire detection, like we saw presentation from Iridium. Or, for example, I've seen the NASA program with a web-based application for dynamic mapping. So basically, at the moment, we are collecting more and more data, and it's happening actually the same what is happening in the AI modeling, that we need to integrate the different predictions that we have, the classic predictions for the weather, together with these new AI systems. Then I believe that the next part, which is interesting to consider in the paper, would be on the 3D printing and composites. So there is this new development of the propellers, which will be cost efficiency and product customized. And finally, a subject that we work more here in Delft would be towards development of the digital twins, towards simulations, and, for example, to advanced controllers. Now, Johnny was talking about this designing already for gusts for 100 miles. I do not know if, so you can achieve something from design. But I do know that in a control, you have this fault tolerant control where you can achieve quite an stability. And if there is a problem, it can really be helpful in avoiding this kind of firefighting. So I think that basically the application of the wildfire management, I put a new slide. So it will be in, for example, in the rapid aerial reconnaissance, in a supply and transport, personal transport, and autonomous missions. So, for example, the real-time mapping of the terms of the zones, the thermal imaging and the sensor equipped, deliver gear, medical aid or water, evacuate crews or civilians. So all these are application for the wildfire. Now, the future vision is to imagine a kind of coordinated fleet of the eVTOL, which will autonomously monitor, map, and also support firefighting in real time. So the next steps probably will be to have pilot programs in high-risk areas, to establish partnership with public safety agencies, and to invest in scalable eVTOL platform. Then I said, okay, call for action. Imagine, and I gave this question to the ChatGPT, and it was I received that actually it gave me 3 areas. And they relate to a rapid aerial reconnaissance, to supply and personal transport, and to autonomous missions. At the moment, this is what I put for the white paper. I created a structure of the white paper, and I'm going to take the conventional approach, and then I'm planning to write a part which is related to the AI and the firefighting, and as well to write a part on the control. I would like to give the floor to you and think of some discussions for this kind of paper.
Yeah, everyone. Thank you, Marilena. Well thought out and interesting what you get from the ChatGPT feedback. Definitely helpful. Sometimes they think of a few things that we might have missed or whatever. So everyone, please, any thoughts, suggestions, recommendations?
Yeah, hey, Johnny, this is Greg with Pivotal. A couple of things from my perspective, and I think Kirk will probably be able to speak as a practitioner or former practitioner on this, and relating to organizational barriers of adapting these types of technologies. My prior time with AeroVironment, where I was trying to commercialize some of their military products for this very market, one of the things that I came up against, and it's probably rolled in to probably a broader line item, but the agency's ability or desire to allow non-traditional aviation assets into the operational stack is a big deal, and that resistance comes from primarily the heli and fixed wing pilots, as anybody might expect, right? So you've got different altitudes where different things happen at different times. That is something that we're going to have to better understand and really message effectively back to those agencies so they understand the threat environment or how we can possibly mitigate that threat environment. The next is a question: why are we thinking about 100-mile-an-hour gusts? I live in Southern California. I had fires all around me during that time frame. So I noticed a house that I put a bid on burned down in the mountain fire last year. So I'm glad they took the second person, because I would have lost everything. But as living in this environment, everything from 70, 80 miles an hour gusts were grounded. So why are we looking at 100 miles an hour when it's not going to happen? Over.
The question, well, let me probably rephrase my thought, and Marina, please speak out as well. But I don't think I'm trying to set 100 mile per hour as a absolute design goal. What I'm more thinking of is that, at least in this round of experience, I mentioned on one of the meetings that my sister living in Pasadena, they have a few minutes notice because the wind blows so fast and changing directions so fast that typically you got even half an hour, 1 hour advance call to start to evacuate and so on. This time around, a few minutes. They barely get out alive and the house is totally gone. But I have to admit that I have not putting the gust tolerant as design criteria. I was thinking, okay, yeah, just typical fly aircraft, fly vehicle. But what got me thinking was the differences between eVTOL compared to the fixed wing airplane. Fixed wing airplane, I mean, you generate that much lift on the airfoil and the fixed wing, that the gust load, almost by default, between the speed of the airplane, the type of design, utility criteria, or general aviation airplane or heavy duty airplane, similar to some degree, the helicopter, we are constrained on what we can design the vehicle to handle or operate safely. My question is not a set firm deal, is that learning that this time around it happened and it could happen again. And since we have many airplanes grounded during the operation, if we try to use the eVTOL to rescue people, to get people out of the harm's way, and if we're grounded, then we cannot get them to the safety zone. So my question really is that maybe we can get some feedback from the people with the technical understanding and knowledge about the eVTOL design. Is okay. eVTOL is a little bit different than conventional airplane design, that we control the airplane in some cases differently than the other airplanes. Can we leverage that differences? Does it give us potentially configure some design with the specific control system, control law, that can survive or operate safely in a higher gust environment? There's any flight vehicle, and there's always an upper limit. I don't think we can defy physics, but there are some differences between the eVTOL configuration, systems, control. So I'm interested to find out, can we do better? That really is my point, yeah.
Can I also give an answer to this? Because I thought of this. I think that our paper would like to be a kind of future to see the possibilities. And, I will make a parallel with what happened here in the Netherlands. This country is under the sea level, the whole south of Holland. And in 1950s, they had one scenario where the sea just flooded the whole south of Holland. And at that moment, there was one engineer who was predicting this. He was predicting that those dikes were not strong enough and that the sea, there is a certain condition that will appear. Now, that condition appeared and they had a big flood. Afterwards, the government decided to build such a huge barrier to stop the sea, and they call it the Delta Works, the Delta Werke, you see it there. So there are all kinds of sluices which are closing the sea. Now, from that moment, actually, it did not happen any big disaster in the Netherlands. But it seems that in the last years, they had started to close more and more the gates, because the climate is changing. So you see that the sea is coming more and more towards the Netherlands. They are already now thinking of a Delta work number 2, because they realize that if you need to do something. So I do believe that the climate change will also bring in the future really more extreme situations. And I do believe that we need to raise this point in a white paper and see what would be the danger and how would we build this resilience. And it can be with the AI. Probably the AI will create some scenarios that we are not able to see at the moment. Of course, AI has a lot of knowledge in the past, but probably I don't know what kind of scenarios. So I think what is happening at the moment with all these predictions and creating scenarios and going in parallel with the developments with weather prediction, with some other technologies, will be fundamental on how to develop the future firefighting. So that was my thought. So yeah, I would like to introduce one chapter in a white paper where we really discuss this kind of one unique scenario that can happen and that people are not prepared for.
Well said. Thank you. Yeah, so, to follow up on the 100-mile-per-hour gust, it's more like a challenge to ourselves, to the industry. Say, what can we do to make it more mission ready, more capable in various conditions and so on. So, other thoughts? Greg, thank you very much for bringing it up.
Thank you very much for the presentation. And I put a couple things that are coming to mind in the chat there that I see on my LinkedIn feed. And I've actually just been asked to contribute to, let's see, where was it? This is an Ohio Federal Research Network, Parallax Advanced Research on specifically developing a trustworthy AI coordination system for failure-resistant, low-altitude, large-scale drone management and vertiports. So whether it's a 5-mile-an-hour breeze, 100 miles an hour, whether water's nearby or not nearby, whether we're putting destructive fires out, using artificial intelligence to decide when healthy fires should continue to burn. This is very important. We have got to go back to healthy fire and combustion of fuels so that we avoid destructive fires like we saw in LA and Maui and so many other places, Camp Fire, Oakland, Berkeley Hills a number of years ago. And to have coordinated systems, tons of challenges, including some of those links about conflicts between drones or heavy lift drones, crewed or uncrewed airborne systems making contact with some of our most effective airborne suppression resources. So a lot to be considered. I think AI is going to be part of it, the Internet of Things, spaceborne, early sensing, detecting fires early and deciding which ones we need to suppress while something can be done about this. And thank you for your research. I'm happy to chat more offline. Those are some of my first thoughts, and it's aligned with a long-term need that I've been getting pings on for a decade, I would say. Thank you.
Thank you. Yeah.
Yeah, thanks for the input. That's a lot of information right there you put on the chat, and thanks for the discussion. I know we always count on you for a lot of insight into this field. Other thoughts, suggestions?
Also
Question?
put on the chat a link to the president's executive order on wildfire I encourage, if you haven't seen that, to really take a look at it, download it, and better understand how it affects the conversations that we're having going forward.
Sounds good.
Yeah, I
Hey,
know there have been a number of different, Vertical Aviation International, others have really come out highlighting the real potential dangers of that executive order. So I encourage everybody, like you said, to take a look at that.
And following on with what Greg was saying, the other thing is drones for suppression are going to be somewhat effective, but they're going to be most effective when we have a human in the loop in a coordinated manner, which where teams, VTOL crewed teams like Greg's and others might be able to get us the human to have an eye in the sky early, might be able to get on the ground and put out a fire without suppressant, just with a hand tool while it's still small. It's all part of to me, the advanced air mobility data reasoning fabric greater ecosystem that all of you are actually building. Thank you for that.
Thank you.
good point. Good point. Yeah, Mike, thank you for Mike and Kurt, thank you for pointing out that that order we all should be sensitive to and make sure that we are fully up to speed on what's going on there.
Hi, hello everyone. Thank you so much for the presentation and for the white paper. And Dr. Pavel, I'm not sure if this would be applicable for the white paper or potentially for a work following the white paper, but at Mighty Fly, we are building a technology for this, for both, fire detection, fire suppression. We are in discussion with fire departments, government agencies, Department of Transportation, to try to offer a solution for this. And we are working very hard to try to identify like proof of concept opportunities for us to launch next year. We are targeting mid-2026 and later for us to, test our aircraft in a real world scenario and, and get feedback, right? Get feedback from fire departments, various agencies. So we're open for a partnership there, whether it could be a follow-up from your white paper, which I believe is going to happen now in a very short term, but let's say a study together in the future of our aircraft in the field, real world applications, learnings, and so forth, improvements that we can make, and also different types of we understand that there are current tests on different types of how's it called? Sorry, the different chemicals, right, that can be used to combat fire, in addition to liquid form, like granular forms, and how our technology could be utilized to kind of help them spread over fire. An aircraft that doesn't have the problems of, since it flies autonomously, it doesn't have the problem of lack of visibility, or that can only fly during the day. We hear that those are some of the problems that the fire departments share with us, that the current technology that they have with the aircraft is that it can only fly during the day and when there's visibility. So we could fly anytime, at night, heavy smoke, potentially, since we don't have a human on board, get closer to the fire site to deploy those goods, get better imaging information, and so forth. So we would love to partner there. And thank you so much, everybody, for this discussion. It's very valuable.
Yeah, that's great. You guys have been engaging real world, you're already working on it. We'd love to have your insight, to be part of the included in our white paper discussions. Yeah, absolutely.
Mm-hmm.
Yes, thank you. I have a lot of in the chat, so I will have to try to see, and I would be interested to have further discussions. So I think the momentum is good. There is a lot of technology going on and development. So I think it would be nice to put as a TVF group on public services white paper on the wildfire and the new capabilities and how it would be in the future.
Mhm.
Yeah.
Thank you.
Okay, thank you.
Any other thoughts? If,
John, I have to leave. Thanks, everybody else. I'll see you soon. Bye.
hey, okay, all right, thank you.
Something I would like to add a little bit here is that we need to be cognizant of the downwash and outwash effects, particularly of eVTOLs involving these fires. So I would actually argue rather than deployment of a fire suppressant, it should be more an evac situation for human beings. My family was actually in Southern California, and there was a real dearth of rally points to be able to evac people out. They were largely on their own to try to get out. And I feel that particularly eVTOL with the downwash and outwash issues that FAA is examining right now from a safety case, particularly in EB 105, has particular risk involving wildfire. Kansas, specifically, part of my portfolio is dealing with the Beyond program, with which we're a lead participant with FAA. And for the next 4 years, that was codified in FAA reauthorization. Public safety is a key component of that. And we do a lot of Part 137 operations, and Part 137 operations oftentimes are the same players that are involved in aerial fire suppression. And we have to be cognizant too of what was brought up about working at night is a real game changer. Particularly in tree canopies. It can't be done with crewed aviation. It could be with uncrewed resources. The problem you're going to run into is so often the items that are put in with the water can't be dispersed particularly well with the nozzles. So we're examining and doing work right now for the next 4 years and beyond for the Kansas LP to be able to use surfactants, particularly to work daytime operations with the contracted Forest Service vendors that are trying to use air tankers, and then at night be able to augment that with uncrewed systems so that you have 24-hour operational efficiency to be able to fight these fires. We don't have fires in an urban environment, thank goodness, but we've seen New Jersey this week has had these. And going forward, these types of fires are going to be a rural, suburban, and urban dynamic that's going to be. Kansas, our state is 3 million people. We actually have an urbanized area in the eastern part of the state, but most of the state is rural. So being able to use a specific approach for fire that is agnostic to the resources statewide deployment wise, but that are able to do what is best for the area where the fire is so it doesn't get worse is really key. And so I would challenge this group to not just focus on eVTOLs, but also look at like a short takeoff and landing hybrid drivetrain, like an Electra Aero that can take off in about 250 linear feet. Potentially their cargo, just spitballing, I don't work for the company, but looking at the technology, it makes a lot of sense to be able to have a system that would have a larger capability akin to a legacy air tanker that could be able to actually, like this group noted, work at nighttime, uncrewed, so that you have a TFR in place, you have an air boss that's able to go ahead and be over everything else in our state to be the Kansas Highway Patrol, and then be able to do these operations 24 hours a day with ground assets, with uncrewed aerial assets at night, and then adding air assets that are crewed in the daytime.
Very interesting. I liked your thoughts, the day-night operation that fulfill different missions. That's great. I love what you guys are already thinking about working on this. That's encouraging. That's encouraging. That yeah, I agree. Marilena, what do you think? Yeah, even though we're talking about eVTOL, but I think we're in general a broader definition of new technology platform systems or whatever can do the job. Yeah.
Yes, thank you. Yes, good points to think of and to include. It will be difficult to write a white paper. It's
Yeah,
a good
we have
white
to
paper
have some
book.
boundaries. Yeah, I agree. Yeah, I agree.
Yes.
But Brian, you bring something very interesting point, and you since you're so close to the real world there, we'd love to have more of your input on this.
Happy to provide input.
Good to hear.
One more thing I would add is, and this is something that I truly don't have the answer to, and our research in the next 4 years is going to be able to meet this out a little bit better. But we have heard, particularly from producers, agricultural producers, and you have to understand the culture of Kansas is very decentralized. Most of our fire districts in the state are volunteers, neighbors helping neighbors. Then when there's a massive mutual aid situation that they can't contain anymore, then it becomes a mutual aid for a statewide asset management, asset deployment from the adjutant general or even the governor. And so, so often people in our state want to be able to take care of themselves and neighbors helping neighbors again. What we found is that they don't, unless they're already a Part 137 pilot and have an air tractor that they use, they don't have an aerial asset. But being able to procure a particular UAS, and we're examining different platforms that we're already partnering with for the Beyond program with FAA, but being able to take an asset that they already have for Part 137 operations and being able to throw, hypothetically, water on a fire line for a grass fire, even if it's only being able to throw 40 gallons onto something, as the gentleman before noted, if you do it early enough, maybe hand tools would be sufficient. This is that same kind of idea, being able to get it in a time critical need on site by the individual who is closest to it rather than letting it percolate is profoundly helpful. And a sidebar of this, I would argue, is a policy notion. We partnered with the Part 137 player Helio to get a 44807 exemption to allow a one-to-many, which was specifically 1-3 for a large drone, which is of course over 55 pounds. And I would argue that that type of one-to-many waiver or exemption would be a real game changer if a producer or property owner, manager, even political subdivision were able to go ahead and have a handful of aircraft, even being able to throw 25 gallons at the most time critical notion after ignition aerially could be a real force multiplier for individuals. And so that's the policy side of it as well. And that's actually really what I deal in more for the Beyond program with Kansas and the FAA partnering.
Interesting point, and good point, because that's kind of in line with what we've been talking about, that the faster response, even if you're not completely controlling the fire, the one that you want to control, you have a better chance if you respond faster, earlier. We're never going to replace the DC-10 air tanker, but the early prevention or early response should be able to make a huge difference in the outcome in many cases. Yeah, good point. And you have a lot of real world the system operation knowledge, so really love to pick your brain more.
I promise I'll stop being so verbose. But the last thing I would argue in this, or at least proffer to the group, is that eVTOL, particularly air taxi operations, mobility as a service, is very big in the media. And I'm not saying it doesn't have that place. It clearly does. But again, I would proffer to the group, advanced air mobility is not going to look the same everywhere. Kansas and rural Massachusetts are going to look profoundly different as far as the use case is concerned for advanced air mobility compared to Southern California and the New York City Metroplex. And then there's a pretty vast chasm in between where that falls. And in my state, the ConOps that we keep coming to for advanced air mobility overwhelmingly is going to be a public safety use case. Specifically, fire is one that we hit along with other natural disasters, because these aren't monetized operations like air taxi mobility as a service. However, they're profoundly value added. And, firefighters don't charge fee for service like an air taxi operator theoretically would. However, it is profound value for stakeholders and citizenry. So it also has a component for proliferation of the technology across environments and across ConOps. And please, that's the last I have to say, but happy to engage.
Sounds good. You kind of hit right on the jackpot.
Yeah.
That's what this working group has been talking about all along. So you're in the family. Thank you. All right. Well, if nothing more, well, definitely we don't have to bring up everything during the meeting. I mean, off meeting, please contact Dr. Pavel and myself and others so that we can make major progress and make a difference out there in the field. All right. Well, we have a few minutes. If you guys like, we shift to the lighter side. Marina, if you would unshare.
I stopped sharing, so
Oh,
yes.
okay. Let me see if I can share mine. Uh, Can you see it?
Yes, we can see it.
Okay. All right. Anyway, shift the gear a little bit. This is the fun side. Went to Sun and Fun in first week of April in Lakeland, Florida. I haven't been there for a while, so I have to say it's a little bit eye-opening how big it has become. To look at the number, there's over 200,000 people attending this year, so it's kind of fun. Now, if I can figure out how to advance the slide. Oh, there you go. We have a broad range. For example, the some of you recognize the XFV1 from way back. It's a power lift, right? I happened to saw this parked out, in the corner. So I said, wow, I gotta take a picture of this one. And that's what I call the part of the history, vertical flight history. But at the same time, you look at on the right-hand side, we have flight demonstration by the Wings Aviation that for the package deliveries, dropping down on the tether line, and once it hits the ground, the aircraft never land. It just drops the package and goes away. That was kind of the future advancements. Of course, we can't talk about power lift without looking at a helicopter. I know we don't, by FAA definition, helicopter is helicopter, but to me, if you apply power, it flies. That's power lift, right? And so we have quite a few helicopter over there, and static display, of course. Just fly operations over the place. You have to be at the right place at the right time to catch some of the impressive flying out there. And of course, you can't have a Sun and Fun without major concert, especially amongst all the airplanes around you. But if you look at the right-hand corner, some of the guys have the best seat in the house on the concert. And now here's what I call the power lift. It's a partial power lift, I call it. You see the afterburner fired up right there. So that's what I call the partial power lift because some of the wing is still generating some lift. But the next one, oops, sorry, that's the same one. So I'll see if I can advance to the next one. Yes. This is what I call the full power lift. Now, that is power lift. Oops. All right, see if I can move on to the next page. There you go. I thought I'd share this picture. It's P-51, F-16, and F-35, each represent the master accomplishment in aircraft design of its own era. So I thought that's a great picture to share. And of course, we can't talk about power lift, eVTOL, AAM without looking at the actual airplane pivotal over there with the booth there, and you can see that that's our test pilot or demonstrator pilot getting ready, doing walk around and getting ready to fly. And this is how if any of you haven't seen the pivotal aircraft taking off, this is how they take off.
Is test pilot 10. And yes, you can get where they fit. Helix available right now for 3 orders. And the contact, the website is simply eVTOL.
That unusual way of taking off. Now, of course, if you take off, you have to come back and land.
That's how they works.
Of course, I always like to share one of the pretty pictures I have there. Now, this, for any Navy aviator, this is for you. Now, why is it related to vertical flight? Well, because all the images here are drones, and that's a well-coordinated, programmed, massive drone operations there. And that's another one. That's some programming. Now, of course, you can't have an air show without fireworks, right? So there you go.
Thank you.
All right, that's it, folks. And thanks for attending. And we have some fantastic discussion, and hope you also have a little fun with some of the videos, pictures here. And again, thanks everyone for excellent contribution for this working group. I'll see you guys next month.
Thank you.
Thank you. Thank you all.
Thank you, everyone.
Thank you.
Thank you. Bye.
Bye. Bye, Johnny. Bye, everybody.
Hey, Tom, you still there?